Hi students, myself Samjad Zakaria, Faculty of Chemistry, Global Education Center. So, I'll be teaching you the very first topic in our syllabus, chemical equations and reactions. So, before we move on to what is a chemical equation or what is a chemical reaction, we have to understand. We have studied in our lower classes that there are two kind of changes. The very first one is a physical change and the second one is chemical change. We have seen it from our 7th standard, 8th standard. Yes, everyone are thorough with what are physical changes and what are chemical changes. Basically, when we define a physical change, we tell that physical changes are those changes in which no new substances are formed. Example, melting of wax. When you melt a wax will be turning into a molten form. From that molten form, that wax, when you cool it down, it will turn back to a wax. So, whatever the substance you had converted into a new state. From that molten state, you are getting back that wax. So, no new substances are formed and physical changes are reversible. You can get back the product, whatever is obtained, you can get back. That is reversible changes. But speaking about the second change, it is a chemical change. In a chemical change, new substances with new properties are formed. It is exactly the opposite of a physical change. That means you'll have a question. And let me ask you a question. If there is no chemical changes, how this world will be? If there is no chemical changes, how this world will be? Yeah? No rusting of iron, no photosynthesis, you take no digestion, and all these are a kind of a chemical change. Once the food is getting digested, will you get that food back? No. Photosynthesis is happening because of, it. Yeah? So these things, these are chemical changes which are happening. So happening of chemical changes are very important. So whenever I teach you chemical changes, it's new substances are formed. Suppose rusting of iron. Iron, you see that shiny material, iron, that metal, when it is exposed to air or when it is exposed to moisture, what will happen? You see that brown coating or that brown powders you can see on the layer or on the surface of iron. Yes? That is what? It is nothing but in chemistry we call it as rusting of iron. What is that rust? A chemical name is ferric oxide, Fe2O3. Fe2O3. Now, all these things we'll learn in our next sessions when we discuss about corrosion and rancidity from this chapter, the last topic. Yes. Now, rusting of iron is a chemical change. Now, what it is to do with our chemical reaction? Chemical reactions are nothing but chemical changes. So, what are chemical reactions? Chemical reactions are the processes. It is nothing but a process in which new substance with new properties are formed. So, in order to understand what is a chemical reaction, let me give you an example. I have drawn here an experiment in which I have taken a burner, I have taken magnesium ribbon and a watch glass. Now, what I am going to do is very simple. Listen, I lit the burner and when this magnesium ribbon, you keep it for prolonged time or when you expose this magnesium for more amount of time, layer of oxide is formed on magnesium. Now, when layer of oxide is formed on that magnesium, it is not at all reactive or it will not burn. Meaning to say that layer of oxygen is very much stable and it will prevent the further reaction. So you have to take a sandpaper, you have to clean that magnesium, you have to clean that magnesium ribbon and remove that layers of oxide so that the underlying material or the underlying magnesium is exposed to the fire. Now basically when you call fire, it is nothing but oxygen. Any substance will burn with the help of oxygen, so oxygen is a supporter of combustion. Yes? Now, you take that magnesium, it's important why you use or why you polish or why you use sandpaper or why you polish that magnesium is very much important. It's one of the important questions that can be asked. Yeah? Now, when you take that magnesium, once you remove that oxide layers of magnesium, when it reacts, when it gets combusted with the help of oxygen, that means magnesium is reacting with oxygen to give you magnesium oxide. Now, when you burn this, the powders of magnesium oxide will fall onto this watch glass that is white in color. White in color. So, a new substance is formed. Magnesium is giving, when you heat it in the presence of oxygen, it is giving you white powders. That means a new substance with new properties formed. Now, magnesium reacts with oxygen to give magnesium oxide is an example of a chemical reaction. Now, whenever you have a reaction, it is important to show it how that reaction occurs. For that, writing chemical equation is very much important. So, whenever you speak about reaction, the substances which take part in a chemical reaction are known as reactants. In this case, magnesium and oxygen are reactants. Now, the new substances produced as the result of chemical reaction is called as products. Now, what are products? Now, whenever these two reactants are getting reacted, substances of magnesium and oxygen is getting reacted, you will get a new product. Now, magnesium oxide is a product. So, always you write your reactant in the left hand side and the product should be written on the right hand side. So the substances which take part in a reaction are reactants and the new substances which are formed due to chemical reactions are products. Now, in any chemical reaction there will be reactants, there will be products. There will be reactants, there will be products. Now, you have to convey this information. This information need to be conveyed, how that reaction is taking place. You should write that reactants, you should write that product. So that reaction need to be conveyed in more informative way. Now how to make this more informative? That means you have to write it in the form of a chemical equation. Now this whatever I have written, magnesium plus oxygen gives magnesium oxide, is a word equation. Now, in order to make this word equation more informative, I have to use symbols and I have to use formulas. Now tell me students, how will you write magnesium? Magnesium is written as Mg. Yes? Plus oxygen. Oxygen is a gas. So how will you write oxygen? Oxygen is O2. Giving you magnesium oxide. Magnesium oxide, how will you write? The formula. Magnesium is 2 plus, oxygen is 2 minus. Yes? Mg 2 plus, O 2 minus. Equal charges will get cancelled. You will get MgO. Now, whenever you write chemical equation, so chemical equation is what? It is symbolical representation of the word equation using the symbols and the formulas of the reactants and products involved. Now, see guys, how to make it still more informative. The chemical equation will look more informative if you write the physical states. What are the 4 physical states that are available? First one is gaseous state. It is written as in small g. Now, the next one is a liquid state, which is small l. Solid state, the third state is solid state. You have to write it as yes. And the fourth state is an aqueous state. You have to write it as AQ. You have to write it as AQ. Now, these four states represents the physical states of the reactants and products. Now, magnesium is a pure metal. It is a hard metal. Yes. So you should write it as a solid. Now, how will you write this? Magnesium should be written as yes. Magnesium is a solid. You know oxygen is in which physical state? Oxygen is in gaseous state. So you have to write O2. You have to put G, indicating that oxygen is in gaseous state. Next. Now magnesium oxide, you have seen when you burn this, you will get the white powders. White powders, are they liquid? No. Are they gas? No. It is a solid. So you have to write yes. Now this is how you make an equation more informative, by writing the symbols of the substances involved, by writing the formula of the new products which is formed, and the physical states of those substances which are involved in a given reaction. So representing a reaction, we have an equation. Now here a new substances is formed. Yes. Now let's take next example, where I take an aqueous solution of lead nitrate and an aqueous solution of potassium iodide to give lead iodide and potassium nitrate. So how will you write this? Lead nitrate is written using formula PbNO3 twice. Learning the valence chart is very much important for writing the chemical formulas. So lead nitrate is written PbNO3 twice plus potassium iodide is Ki, giving you lead iodide. Lead iodide is written as PbI2 plus potassium nitrate. Potassium nitrate is written as KNO3. Now, this is a solution of lead nitrate and potassium iodide is mixed. So what I have to write? This is an aqueous solution. Solution means aqueous. What is an aqueous state? Some substances which are dissolved in water. Some substances which are dissolved in water are known as aqueous state. So lead nitrate is an aqueous. Again, solution of potassium iodide is an aqueous. Now you see here, guys, an insoluble substance is formed. Whenever these two solutions are mixed, an insoluble substance is formed. Now what is an insoluble substance? Insoluble substances in a given reaction are known as precipitates. It is known as a precipitate. Here I have written it as PPT. It is known as a precipitate. So whenever there is a formation of precipitate, you can call a chemical reaction had taken place. Whenever in the first example, there was a change in color. Whenever there is a change in color, you can tell that a chemical reaction had taken place. Now, instead of writing precipitate, again it's an insoluble substance. It is again a solid, and you can use the downward arrow to identify lead nitrate and potassium nitrate. Again, it is a clear solution and it is again aqueous. So this is the second example. Now let's move on to the third example of chemical reaction. Listen, I take zinc granules. I have taken. Now tell me the physical state of zinc granules. I have taken a small granule, so it is a solid. Now I am mixing with dilute sulfuric acid. Sulfuric acid is again in which form? Aqueous form. I have diluted the sulfuric acid by adding more water. So something is dissolved in water, aqueous form. Now giving you zinc sulfate and hydrogen. This reaction is nothing but metal is reacting with an acid to give you salt and hydrogen gas. Now how will you write zinc? Zinc is Zn plus sulfuric acid, you know, H2SO4. Sulfuric acid is H2SO4. Zinc sulfate, you know how to write it. ZnSO4 plus hydrogen H2. When it is a gas, you can write with the upward arrow. When it is a precipitate, put the downward arrow. When it is a gas, put the upward arrow. Now zinc is a solid. H2SO4 is an aqueous state. Zinc sulfate, again it is in aqueous state. Hydrogen, it is a gas. Hydrogen, it is a gas. Now there is an evolution of gas. Whenever there is an evolution of gas, you can call it as a chemical reaction had taken place. Now, in this conical flask, if you touch it, after the reaction had occurred, if you touch it, you can feel that warmness, you can feel that heat, meaning to say that there is a change in temperature. So whenever there is a change in temperature, chemical reaction had taken place. So when you see this, now zinc is a solid. From here solid, you will get zinc sulfate, which is an aqueous state. So zinc had changed its state from solid to aqueous. So there is a change in state. You can call it as a chemical reaction had taken place. Now, here also there is a change in color. The precipitate is yellow in color. Lead iodide which is formed is yellow in color. Now when there is a lead nitrate is changing into a precipitate which is precipitating as yellow color. Now since there is an yellow color, you can call there is a change in color, a chemical reaction had taken place. Now any one of these 5 characteristics happens, either it's evolution of gas as in this example, formation of precipitate as in this example, change in color as in this example, change in temperature. When you touch this conical flask, there is a heat you can feel. So change in temperature as given here, change in state as given from solid to aqueous. Now whenever any of these characteristics happens, you can call a chemical reaction had taken place. So I'll stop today's session on basics of chemical equations and reactions. So I'll move forward, or the next session we'll study more of balancing the equations. So till we see, bye.